I wanted to share a problem with you that was, I guess this was rated as a sophomore level problem, 10th grade problem in US high schools. And the question is, the sum of a natural number and its reciprocal is 65/8, find the number, okay? So a natural number is just a counting number like 1, 2, 3, 4, 5, 6. And so we're given the condition that the sum of a natural number and its reciprocal is 65/8. We're supposed to find the natural number. Now, just a little bit of review on what we mean by reciprocal. Say, for example, 11. 11 and 1/11 are reciprocals because their product equals to 1. If you multiply 11 times 1/11, you get 1. The product, 11 times 1/11 equals to 1. Also, say 7/3. Now, this is a natural number, but if they were asked, you were dealing with fractions, 7/3 and 3/7 would be reciprocal, all right? Because their product is also equal to 1. So sometimes a reciprocal is called the multiplicative inverse. But in any event, we're told that n is a natural number, and so this is more in keeping with what we're talking about right here. Now, so we just directly translate the problem. If n is the number, then 1/n is its reciprocal in much the same fashion that happened right here. Okay, now it says the sum, and the sum, of course, connotes addition. Now, at this point, we try to create an equivalent equation that we can factor, is what the process is right here. And so what I did on this step right here is I multiplied this expression by n. Notice that n times 1/n just gives you the 1 right here. Then n times n is n squared. And of course, n times 65/8 is 65/n. Okay. Now, often in mathematics, it's useful to, if you're trying to solve an equation, to get 0 on one side. And so if you subtract 65n/8 from this side, you get this equation right here. Okay. Now, believe it or not, this is all equivalent to this equation. If we can solve this equation, then that will be the solution to this equation. Now, again, you could work this directly using the quadratic formula, or if you multiply by 8, you get something that perhaps is factorable. And that's what I did right here. I multiplied this expression by 8, right? You see how this 8 cancels? We cleared the fraction, so to speak. And it turns out that gives you a very nice factorable form. Notice that 8n times n gives you the 8n squared. And then 8n times minus 8 gives you minus 64. And then this gives you minus 1, which accounts for the minus 65n term. And there's a little bit of trial and error here, but it's not too much if you know that the 65 is the requirement and 8 kind of naturally fits the bill. You could have tried 4n and 4n, but you would have found there was no solutions there. And so again, this is trial and error. Now, if you don't like that, you can just substitute this into the quadratic formula. But the benefit of writing it this way is it makes it real easy to identify the solutions. And the solution we're interested in is n is equal to 8. Because remember, it did say it's a natural number. 1/8 happens to be the reciprocal here, but it did ask for the natural number. So technically, this is the answer, although this is the reciprocal of that answer. And so you'll notice right here that 8. So what we have right here is 1/8. And y'all, I'm going right back to this part. 1/8 plus 8. Okay, now it becomes a common denominator problem, and you'll note that 8 times 8 is 64. So this becomes 1 plus 64 over 8. And of course, that's what we set out to prove. This is equal to 65/8, right? Which is what the initial condition said right up here, that they had to sum to 65/8. So we do get 65/8. Now, y'all, there is another approach here. It may not be favored by a lot of math teachers, but what you can do, if you just looked at this, let's just say you started with this and you didn't consider any of what I just did right here, where we directly translated to get this statement. If you just started with 65/8, you could observe, it doesn't take much number sense to notice that, again, if you just start with this is equal to 64/8 plus 1/8. That's just properties of fractions. 64/8 plus 1/8, just by inspection without doing much thinking, is certainly equal to 65/8. All right. Now I know this is a little overkill, but some of these problems, the composers didn't go to a lot of trouble to make nice problems where you could guess. In this particular case, guessing, an educated guess leads to the very same solution as going through all of this right here. But this right here isn't particularly difficult. It's slightly tedious, but you directly translate it. The sum of a number and its reciprocal is 65/8. Multiply by n to get to this step right here. Get everything on one side and set it equal to 0, which is often a good strategy when you're solving equations. And then you could solve it directly from here using the quadratic formula, but I prefer multiplying through by 8. You get an expression that's pretty easy to factor. Factoring is a great idea because you can set the individual factors equal to 0. All right, hope that helped.